it's Mrs. Shannon. Sorry, I'm not going to be there for 7th hour. I am giving you guys a little bit of help here with this screencast since I'm not going to be there. Remember, I told you that by doing these storylines, at some point you will feel like you are floundering in the deep end, and I will give you a little bit of content, just enough to keep you afloat as we go. Today may be one of those examples. So in part 1 of Lulu, we used field observations to come up with a hypothesis. In part 2, we added geographical information and data to refine our hypothesis. And in part 3, we researched online to further see how our ideas are coming together. Today, you should be starting part 4, and if we finish with part 4, you can even begin part 5. I will have both available. But note, whereas we've been looking at data that we can see, whether they were the observations, whether seeing physically the location.
Andrea Sandoval, please come to the office. Andrea Sandoval, please come to the office.
Okay, sorry about that. We even have announcements at the end of school. Well, now that we're in part 4, we're going to get to more the molecular level of data. And so we're going to start by looking at karyotypes. Karyotypes are just images of chromosomes that an organism has. You may have seen the word karyotype or heard it. You may have used it. You may know it. You may not be as familiar. This is a karyotype down here. And this is actually, I believe, a human. Here is our lion chromosomes right here. Actually, this might be a lion. Oh, nope, it is a lion. 18. And the way that you can tell is that all organisms, first of all, have one copy of each chromosome from each parent. So for humans, we have 23 different chromosomes, different types of chromosomes. But we have 46 total because we have 2 copies, one from each parent. Now, for lions, okay, they have 19. You can see right here, 18, and then your 19 is these ones called XY, which we'll be coming back to, and some of you already know. Different types of chromosomes. 2 from each parent gives you a total of 38. Different organisms have different amounts of chromosomes. But chromosomes, in all cases, contain sections of DNA that code for specific traits, and those are referred to as genes. Here's a picture that you will be looking at for part 4. You're going to be making observations. Always focus on patterns. And then you'll see that it has different genes identified. You may need to blow these up. Look at the presentation mode to see these more clearly. These letters here are genes. Genes are often referred to with letters and numbers, and that's all the information I'm going to give to you right now because we'll be discovering sort of the coding for genes and how they're written throughout the year as we encounter these karyotypes a little bit more frequently. But each little arrow here is pointing to a different gene at a different locus. Locus is location on the chromosome. So by just making observations, you should be able to complete part 4. Now, there is an Edpuzzle, an Amoeba Sisters Edpuzzle on karyotypes and chromosomes. I highly suggest you watch that and complete that as soon as possible because it will make it a lot easier if you're a little confused by these pictures or what a chromosome is or what a karyotype is. If you finish with part 4, you're going to go on to part 5. Part 5 is going to start talking about genotypes. Genotypes have to do with the genes. And basically, it's what variation of that trait is found in on that chromosome. And so, for instance, and the most simple way to think about this is looking at traits such as, let's go with whether or not your earlobes are connected, okay? Here, attached or detached earlobes. And so there is a gene on a chromosome that codes for it. And you can either have attached chromosome or attached allele, okay, so you don't see like a gap at the bottom, or you have detached allele where you do see a gap at the bottom. And so those are the variations. The variations are the alleles. The combination of variations or alleles make up our genotypes. And so here's a little bit of background that you will need to read, okay, that discusses a little bit about what genotypes are. and how this specific genotype was determined with what kind of data. And it talks about they were collecting blood samples. So make sure that you read through this. It's going to show you some pictures. It's going to give you something called a Punnett square, which I'm not going to stress about right now. Don't stress about how they come up with the combinations. But notice that you can see patterns start to emerge. The whole idea here is patterns. Start looking at the big picture. And then you're going to be given some information here. Again, you're going to look at patterns. So at this gene on this particular chromosome, there are 3 possible alleles that a lion could have. And since they have one from mom and one from dad, you'll see that each of these lions, when they start identifying, will have 2 copies of alleles, or I should say one from mom and one from dad, located for each of these genes. Okay, and so that's why you see 2 letters there. So use that to help you with part 5. Again, amoeba sisters, karyotype and chromosomes will be your friend if you feel like you need more support. I will be at the Move Up Academy. My computer will be open. Please email if you need to. Feel free. I will try to keep an eye out as much as I can with it. Okay, good luck, and I will see you on Wednesday.